Hi, this is the Tempter podcast where we discuss embedded Linux, IoT development, and anything else we find interesting. Your hosts today are Kim, Raj, and Cliff Brake. Hi, Kim. How are you doing today?
Hi, Cliff. I'm doing all right.
Great. So our topic today is the latest and newest changes in the Yoe distribution. So we're going to discuss some of the things that have been added recently that might interest you, and some of the recent improvements. So I feel one of the big things is some of the new platforms. So Kim, can you tell us about some of the new platforms you've added recently?
Yeah, I think we've been always looking for adding more platforms, which are relevant to the users. And we've been basically looking at a few of those. And of late, we have added support for, um, Tegra socks, basically, or in Nano. So there's a project that we have added, which basically implements simple images as of now, and we don't have full Yoe updater support and the full image installer image support yet in there, given that the image format for the Tegra socks is different, and this is like first of its kind that we are adding to your distro.
Mm-hmm.
So we basically are interested in adding more of these platforms in future. So essentially, I think the first one will take some time for us to integrate our Yoe updater support and the Yoe image support, where we have boot root and data for our flash layout support in there, and then now we'll go from there. So right now, we are able to build weak images and the basic images that you can flash using the original flash method that is available today. So
that's great. Yeah, the Jetson, Nvidia Jetson is a very interesting platform because of its GPU and cores and machining and support for machine learning platforms.
Mm-hmm.
So we're starting to see interest from several customers that want to leverage the Nvidia for machine learning and applications where they're processing a lot of data.
That's right.
So that's really exciting to see the Jetson Orin Nano, and we hope to be able to report more on that soon.
Yep.
So the other big thing is the RISC-V. So
yeah,
tell
I think
us about that.
Right. So I think we've been doing a lot of work on the emulator, which is the QME platform for RISC-V. So today we do have an emulator project for RISC-V, 64-bit as well as 32-bit in your distro. So you can basically build a fairly large set of software and test it that way. But been looking at like real hardware is now popping out that's running RISC-V. So VisionFive2 is one of the boards we added recently, and this is based on a Sci-Fi 64-bit implementation, and it has basically a graphical unit as well, a GPU in there. So it's more or less a complete SBC, if you were to say. And so we thought that would be a cool platform to add. So we've been able to add it, and if you look at, we also update. We've added support for the updater, like other platforms that we have. And one of the shortcomings we have right now is the kiosk browser runs on Qt Web Engine, and Qt Web Engine is has Chromium engine bundled in, and Chromium doesn't yet build for RISC-V 64-bit. It does, but it's not upstream yet. So all the port is kind of missing from Qt Web Engine. So, but Qt can come up on this one. So, if you use like native Qt5, Qt6, in fact, for designing your UI, then you're all game in. So that all works fine.
Mm-hmm. Yeah, just interesting that new platforms take a little time for all the different pieces to be ported to it. New architectures like RISC-V.
Mm-hmm.
So what kind of a processor is this VisionFive CPU?
So it's actually, I would say that it's somewhere closer to a Raspberry Pi 3,
Mm-hmm.
in terms of performance.
So it's like a quad core?
It is quad core.
Yeah.
Mm-hmm. And it's basically quite powerful from, what you expect on an SBC point of view. And I think it's, first of like implementations that are coming on RISC-V, I think it'll just get better with time, but I think it's right now at a point where, it runs satisfactorily well, performs well, and I think it's kind of, given all the ancillary units that it has, it's kind of a complete solution that you expect in an SBC era, as at least for your control processor. So,
sure.
I think at this point, our interest was more on newer architecture, because I think one of the areas I like to look at it is, how does the instruction density looks like, and how much of is the code density better, or those kind of things, for the same kind of software. So it's pretty neat from that angle.
Yeah, and it's also useful to build like an entire application stack and try to get it running, because that's where you find the issues.
Mm-hmm.
And that's part of the value we bring with the Yoe distribution, is we're building a fairly complete stack.
Yep.
A lot of complex things like the Yoe kiosk browser, that exercises Qt, Chromium, and a bunch of other things. So
yeah. So you can build like Yoe kiosk image for this platform too. It's just that you won't get the browser.
Yeah. Right. Yeah.
But you'll get the full. If you're building a VLAN profile with Yoe distro, then you'll get a Western desktop that it'll boot into. So
yeah, so the OpenGL works and all that.
Yeah, all that is working.
That's great. Yeah, maybe at some future episode we could discuss some of the code density trade-offs you're seeing and performance.
Yeah, I plan to do a lot of some work in that direction, where I get to learn about various things. Given that our stack is pretty standard, and if we can get it going in the exact same stack at exact same versions on all these different platforms, and we can do a fairly good comparison.
Sure. Yeah.
Yeah.
Yeah, that's one of the advantages of the Yoe distribution is we support quite a few platforms, and it's all in the same distribution, so it is very easy to do comparisons between platforms, like you said, rather than taking a vendor provided Yocto stack for one product and another one for another, and then having to deal with all these different versions of Yocto.
Yeah.
So again, that's part of what we define as a quality BSP. We've recorded an episode on that a while back, what to look for in a BSP. So check that out if you're interested. So along the lines of platforms, there's a new concept in Yoe that we call projects. Can you give us an overview of what that's about?
Yeah, I think that's a good one. So I think if you look into when we add new platforms and new things into Yocto-based projects, we always have two things that drive your policy. One of them is your distribution policies, right? And then those are more like global policies. And there are like, the package-specific policies, which are more like local to the package, or in Yocto speak, they're called recipes. And when you build your full platform, it's kind of a combination of what the machine can offer. We call them like machine features. And then what your policy is about, like what you want at a distro level. Those are like distro policies or the graphics, all that. There is like a whole lot of knobs you can decide what kind of libc you want to use, and there is a whole list that you can do. And then there is some configuration metadata, which is kind of combination of both, right? So there is like combined features. So for example, if there is no OpenGL on the system, then you may not be able to use Wayland as your distro feature, for example. So it's pretty neat if you look at it, how you compose your system. It really gives you a very tight control over what you want to pull in and exactly what you want to pull in. However, it is a little bit of, that it's everywhere, right? So you got like a machine configuration, you got a distribution configuration, you got your package configs and, all those kind of things. And then you have your local configuration that kind of like, where you combine some of these features. So all these policies that you want to specify to build your platform are spread around. And that basically isn't that bad, but it basically is sometimes when you're new to the project and you're not a Yocto engineer, you might find that a little bit daunting, and you might even forget. I forget it all the time myself as well. And so what we kind of said is that we introduced this top level concept called projects. So projects is essentially, if you look into your distro, the top directory is a conf directory. Under there's a projects directory, and then you have a bunch of projects under there. And the projects specify two things, right? What it specifies, what all layers you want to include, right? So if you're building a kiosk browser, you need Qt 6, you need a Meta OE and other layers. So there's a kind of a set of layers in Yocto speak that you bring in, and so that's all stored in layer.conf. And then you got another file called config.conf, which basically is specifying what this project should look like, in terms of what machine it builds for, what are different features it needs in terms of distro. Should it be pinning a particular version of a particular package? libgpiod should be using 1.x, not 2.x, and things of that nature. And graphics, for example, graphics is always a challenge because sometimes you have a same silicon provider giving you a chip that doesn't have 3D graphics, another one has 3D graphics. So what you do all that is you come here and you can really control all that tightly in that config.conf file, and that becomes your project basically. And now you can clone that into your sub projects, because more than often what happens is you evolve that project into something else in a year down the lane, and you might decide to change your SOC, right? So in this case, you really you clone this project, make SOC specific changes in the config.conf, choose the right machine and maybe other things that you need to do, and leave the distro policies as it is, because say your software stack should remain same, for example, maybe, right? So there's all this kind of reuse that it results into.
Yeah.
And if you come from like a Linux world, it's like def config, mindset, where there's one place where you can configure the whole system, sort of. And it kind of like gives you that one place at a top level project.
Sure. So a lot of this, before we had projects, you would have one set of layers for all projects, and we would have one set of conf files, like in conf site.conf, conf local.conf, and so on.
Yeah.
So this allows for each project to have its own set of layers, and like you said, a project specific conf file. And then that allows us to still build things in one tree, but yet change settings. Like one project might be headless, the next one might have a display.
Yeah.
But yet we want to build some of the same pieces of software into both projects using our platform.
Yeah.
So
one thing it still doesn't address, though, is some PSPs you might find that they pin a particular SOM or SOC to a given branch,
Mm-hmm.
and then they don't move that to the next branch, but they move the newer SOM to the next branch.
Yeah.
So, in that case, we still have an issue, because then we'll have to see how do we go from changing the branch in a top level project. We don't have that yet, but we haven't
Well,
run into that issue yet, though.
yeah, maybe we could clone the same BSP repo into different meta directories, and
Yeah,
then
use
like
that.
if like some of the Verisite platforms are on a clear different
Mm-hmm. Branches.
branches. So anyway, this is a step we feel in the right direction that allows us to that makes Yoe better suited for product development, especially when you want to develop multiple products over time.
Yeah, and more often, like you have, I think, you really want this where you have a single kind of a unified tree. Then you can service multiple projects, and give you enough control over controlling the policies of the project, but also reuse as your project is meant for, quite a lot.
Yeah, that's great. So moving on, so the Yoe kiosk browser,
Mm-hmm.
we've recently updated that, or actually more generically, you've upgraded to Qt 6.6.
Right. Yeah. So I think your kiosk browser is a great little piece of software where I think we are basically sitting on top of a huge, technology stack.
Mm-hmm.
This basically gives you a kiosk view. One good feature about this is that the on-screen keyboard is integrated in, so you really don't need any windowing system, or other kind of keyboard implementations that it should interact with the platform. And that's pretty neat, because if you kind of like offer the kiosk, that's all it needs, and it can take over from there. So it's really good from that angle.
Yeah, we really like the Qt virtual keyboard. It's a nice implementation.
Mm-hmm. So yeah, so I think we basically migrated it to Qt 6 earlier this year, from Qt 5, and so recently we basically switched from Qt 6.5 to 6.6, and the browser now builds on top of Qt 6.6, and we plan to keep moving with the next release, and whenever Qt 6.7 comes out, next spring or something. But coding is very, very easy. Most of the time we have to make zero changes. Once Qt changes from major version to, I'm really amazed at that. You really don't have to make much changes in there.
Yeah, that's great. The as I've been testing the Yoe kiosk browser, I have noticed some improvements from Qt 5 to Qt 6. There was a very small rendering problem back when we were built on top Qt 5. It wasn't, it didn't stop us from using it, but sometimes when you first loaded things, there would be a little rendering problem, and then it would go away. But with Qt 6, I haven't seen that. So that's just an example where, moving forward in time to newer software, things do get fixed.
Yeah.
And there's usually some benefit, especially with, like you said, this is a very complex stack, where we're talking OpenGL,
Mm-hmm.
Qt, the full browser stack, and so on.
Yeah, it is, and it's. I mean, you can use a compositor underneath it on top of Wayland, for example. You could use no compositor. You could just kind of like use EGLFS feature on top of OpenGL, or you could just use software rendering and use Linux frame buffer direct from rendering from frame buffer, or you could use it as a XCB, like X client. So I think the experience is almost going to be identical, with Yoe distro on all these different vertical stacks, and so that's really powerful from what it offers and how configurable it is.
Yeah, Yeah, that's interesting. Okay, so there's also been some tooling changes. You want to share what's there?
Yeah, so I think we've been talking about the nice stack that we build upon top, but it's a huge stack, and there are like heavy components in there. Qt Web Engine constitutes some of pieces of Chromium in there, so it's quite large software to build, and so we've been always looking for, hey, can we kind of speed up our builds? So essentially, we've switched to using the LLD linker as default. So LLD comes with Clang and LLVM, which basically we use already for our CC++ compiler as our default system compiler. And LLD just is adding to that list of tools that we are using. LLD speeds up linking quite a bit, and especially for large software like Qt Web Engine and others, the linking speed is kind of 3 to 4x faster. The reason is it is threaded. So if you have like multi-threaded CPUs on your build machines, it will kind of utilize all of them during linking, and obviously general engineering improvements, of course, improves it too. So overall, that's a positive change. The other thing that it does is it basically have identified bugs in general packages that you would see that we've sent patches upstream into either Yocto or the upstream projects to fix those, because the new linkers, for example, don't do they can identify undefined symbols, for example, during build, so you don't really get those issues during runtime, for example. And so this is the default with LLD. It is not default with BFD linker. So usually the shared object gets pulled in by indirect dependency or something, and nobody notices it. But in this case, it can find it during build, saying that, hey, you have an undefined symbol here, and it will fail the build. You can change that, saying, oh, I know it fails. That's fine. But it finds real issues where you may say, oh, it was just working. But we should really specify the library for that missing symbol.
Yeah, so that's a trend we see with Clang and other newer tools is they do more checks and they find more problems earlier in the process.
Yeah,
and it's kind of like CI. The more you can shift all your problem finding, what do you call it, to the left or to the right?
Whichever way.
Whichever way, but sooner in the process is what we mean. Mm-hmm. Then you save time and effort downstream. So
so I think so that and along with that, we are also using the obj dump tool and distributability and other things by default from LLVM as well.
Mm-hmm. Yeah, that's all very, very good. So anything else you want to share today?
Yeah, so I think one thing that might not be as cool, but it is quite a bit of quality measure, is that Yocto has this package tests, and we basically are now able to run package tests inside Yoe Docker. So because we use Docker as our build element, and there are certain things that you need to kind of configure in the Docker for it to be able to run those p-tests, because it is very isolated environment. So you need to forward ports or create those tap devices, or then pass them into Docker. So there is a bit of exercise there, and the good thing is we have all kind of like included that in our default config, and we have also added those, documented them into our local .sh file, so you can read through and enable, disable them if you wish to.
I see.
And so, but I think the good thing about this is if you're using an emulator, it's very powerful because you can run package specific images for tests. So that's very, very powerful, where every package gets tested in isolation, sort of in isolation, because it boots up a minimal system, and just runs the test for that particular package and then shuts it down and then goes on and on and on. Mm-hmm. So you can really test every recipe, in this scenario and get like really good quality packages in there.
Yeah. So we built inside Docker for a long time because when you're maintaining a product over a span of say 5 to 10 years, you want to be able to update your host distribution, but yet not break your build. So Docker has been very useful for that. But now we can run ptests in that same Docker environment. That's even better.
Mm-hmm.
And setting all this up is pretty tricky. There's a lot of commands, like Kim said, to set up ports and all the resources it needs. So this is a valuable resource to know how to set Docker up with a Yocto build.
Yeah, I think it's a hours worth of efforts that people do to figure that option out, and then it's basically very useful for everyone to use it. But when you're setting it up, you're basically figuring it out. Does it work with Docker? Does it work with Podman? Does it need sudo permission? All that kind of things. You really have to spend quite a bit of time understanding the nature of it mm-hmm. before you really go and make it available as a default template. So like other things we do with Yoe distro, this is basically part of the template. And it's the basically most commonly used, but it might give you a good starting point, and then you can tweak it from there.
Sure. Yeah. Well, that sounds great, Kim. Anything else you want to share today?
Yeah, I think we recently got the Beagle Fireboard, so it is also a RISC-V, and it has a little FPGA in it. It's quite interesting. Given that if we in future that might be one of the platforms we might add to Yoe distro as well, especially if you're a maker. It might be a good for Yoe distro to try that out.
Okay, well, we appreciate you listening. Feedback is welcome. Please contact us at all the places we hang out. And until next time, thank you.
Thank you.